In previous lessons, we've talked about some of the air pollutants, some of the common air pollutants that exist on our planet, and then we've talked about some of the consequences of those air pollutants. And one that's commonly in the news and commonly talked about is climate change. So there's a couple things we need to talk about when we look at climate change, and one is the fact that our climate has been changing independently of human activity for as long as we can tell. We've gone through warming trends and cooling trends prior to people ever burning a fossil fuel at all. That does not mean that humans aren't impacting the rate of climate change and accelerating a process. So just want to make sure that everyone understands, though, that we're not the sole reason for climate shifting happens. We went in and out of ice ages way before people started doing anything. But when we look at what's happening right now, um, we just look at a much faster rate of change. And so the temperature chart that you're looking at down below shows it's showing the differences in temperatures that have happened over time. And then you see there's some predicted in there as well. So we can tell for some of our temperatures that happened before we had records at that point in time, we can look at other evidence. We can look at layers in ice cores. We can look at there's other evidence that can be found in mud flats and things like that, where we can tell basic temperatures, and we can also look at how much CO2 gas was in the air. It was in the air at the time. So some of the consequences that happen when the climate warms, and whether this is warming happens because of human activity or because it happens of a natural process, is that generally the things that are colder are not going to be quite as cold. And so our areas that are getting towards the poles, which previously had been much colder, and so what you're looking at, this picture right now, is permafrost. So you're looking at ice underneath here. It's coming up to the water. This is actually a river that's going by here. And then you see the thin layer of soil that's on top, and then this is the permafrost. So this is up in Alaska. This is like the permafrost that's up in Alaska and Russia. And permafrost, because it's frozen, any bits of decomposition and things like that that occur, the methane in particular, that's the CH4 here is methane, that's produced by that decomposition is actually stored in the permafrost itself. And so as it melts, the decomposition starts up again, essentially, and it starts releasing the methane gas. And so we have methane gas that comes from other areas as well. We talked already about food production, and we talked about raising animals for food and how raising lots of animals produces a lot of methane, but so does this permafrost melting. So what also happens, though, is that is thermal expansion of the ocean water. So not only are we having the ice melting, which is adding more water, which is like pouring more water into the cup, as you heat up water, the particles move faster within the water. This is part of physics, that anytime you increase temperature, you're going to increase the particle movement in there, which causes the volume to increase. And so it expands, and so it actually takes more space up, which is why when you boil a pot of water, like you can boil it over, essentially, because all the particles are moving around in the pot and they take up more water. Now, obviously, we're not boiling the oceans, so it's happening on a smaller scale, but we're also talking about a lot more water. So as we increase the temperature of the surface layer of the water, which is really where that temperature change is happening, we're increasing the space that it takes up, which has its own set of consequences. So, we have to look at how quickly the climate is changing and what kind of consequences those have. And if we were to reduce our amount of CO2 emissions and our methane emissions and that, how quickly could we actually cause a change to occur? And so we'll talk a little bit about, in this one, about carbon dioxide, and in the next lesson we'll talk about ozone. So we talked a little bit about what happens when sunlight comes down to the surface of the planet. So just as a reminder, when the sunlight comes to the surface comes to Earth, a few things can happen. It can bounce off of our atmosphere and go back out into space, or it can come through our atmosphere and come to Earth, or it can get kind of trapped up in our atmosphere. If it comes down to the surface of the Earth, once again, some things can happen. It can either be absorbed by the surface of the Earth, particularly if it comes to a darker area. By that I mean darker in color, not that it's nighttime, but that it's darker in color, or it could be reflected back off the surface of the Earth. If it's reflected, then it can either pass through the atmosphere and go back out into space, or it can get trapped in the atmosphere, or it could be reflected back down to the surface. So there's lots of things that can happen as that light comes through. When we talk about the factors here, we're talking about warming, we're talking about reducing the amount of light that actually is reflected back out into space. And so more of that energy is either staying on the surface of the planet or it's staying in the atmosphere. So when we talk about these factors, that's what we're looking at, is how much of that energy is staying here on the surface of the Earth. So if we increase the amount of carbon dioxide that's in the atmosphere, it acts like a blanket, and so it's going to trap more of that energy. So the energy that's coming in from the sun or coming reflected back off of the Earth, back to our atmosphere, it's going to trap more of that heat, and it's going to increase temperatures. If we increase our temperatures of the ocean, then we're going to speed evaporation, which is going to cause more clouds. And it's going to so think about it on like a cold night. You have one night that's cold and there's no clouds, and so it's really, really cold. But the next night maybe there's some cloud cover, and so it's not quite as cold because those clouds actually trap in heat, and so it can increase the temperature in a particular area. Now, it can be the flip side too, because if the clouds accompanied by a cold front, then there could be some cooling that occurs as well. So it kind of depends on when those clouds occur to the impact that it's going to have. When we increase the amount of carbon dioxide in the ocean, it's going to increase the acidity of the ocean as well. So it's not just impacting the temperature, but it's also impacting the water quality as well. All right, so another thing that can happen is that if we increase the level of CO2, remember that plants use carbon dioxide for photosynthesis. And so if we increase the amount of carbon dioxide, we're essentially increasing one of the building blocks that plants need in order to photosynthesize. So it can speed up photosynthesis, which can, at the beginning, speed up plant productivity, but then that's going to slow down when the plants get to their maturity levels. So as they get bigger, it's going to speed up the amount of time that it takes for them to get big, but then once they get big, then it's going to slow down the photosynthesis. You're storing more carbon dioxide during the time that plant is alive, and then when the plant dies, that carbon dioxide gets put back into the soil, and some of it's going to get released back into the atmosphere. The thing about plant life and increasing photosynthesis is that while it does impact, I'm not saying that it doesn't impact at all our global carbon budget. It does, but not as much as the phytoplankton in the ocean. That's where our primary source of photosynthesis is occurring, and that's where most of our oxygen exchange is actually happening, is in our oceans. While some of it's occurring in the plants on land, and not saying we can cut down all the trees, because no carbon cycling is happening there, because we know that it is. It's just there's so much more happening in the oceans than there is on land, which is still a result of photosynthesis. It's just not necessarily thought about the same way. So the same way as carbon dioxide can cause temperature change, some of the other things that we put up into the atmosphere can as well. So soot, like from smoke and things like that, can actually cause a change in temperature, which over time could cause a change in climate. Generally though, it happens like when we talk about soot, usually we're looking at like volcanic eruptions causing long-term change. But we also saw in the Industrial Revolution when people were using a lot of coal, and even in areas where they still are, like in China, that we can have some longer term impacts due to the soot put up into the atmosphere. We've already talked a little bit about the warming and the methane gas in our permafrost. So it's going to help. So global warming, believe it or not, could actually help some areas of the world um, and harm some others. So if you think about areas that are further towards the poles, where it's cold most of the time and they can't grow crops or anything like that, they're going to have a longer growing season as the climate warms. They're going to have less harsh winters, and they're going to have a longer growing season. But the areas around the tropics, the temperatures are going to increase, and it can decrease the amount of agriculture that can happen in those areas. It also will expand out areas of where infectious diseases and insects that carry infectious diseases live. So when we think about right now, like mosquito-borne illnesses, will actually move further out from the equator because those temperatures will stay higher for longer, and so it will they'll be able to survive and then to pass along disease. So there's some unintended consequences and some things that we don't necessarily really think about. When we talk about the ice, so we talked about thermal expansion, right? In the ocean waters, they get bigger, but as the temperature of the ocean rises, the ice that's in it is going to melt faster. So it's kind of like putting an ice cube in a cold cup of water versus a warmer cup of water. Same thing, just on a much larger scale. But ice reflects some of that sunlight back up out into the atmosphere and back out into space. And if there's less ice and there's more dark colored ocean, then they're going to have more energy absorbed by the dark colored ocean, less of it reflected back out into space, and so the ocean is going to heat up more. And so this is what's called a positive feedback loop. It's where a change starts to occur and it speeds itself up and it keeps moving in the same direction. And so you have less sea ice, so the ocean absorbs more energy, which warms it up more, which is going to melt more sea ice, and then it becomes this loop. This is an example of a glacier in Europe, and just looking at records that we have from about 100 years of where the glacier was to where it is now, just showing the receding of the glaciers. So this one is the Arctic sea ice. So this outline of blue here is where it used to be in 1979, and the white part to where it was in 2005. And Greenland, so Eric the Red was a little bit crafty, one of our Viking ancestors. So he was coming across, he was in Iceland, he was coming over here, he was trying to encourage more people to come, and so he called Greenland Greenland, thinking, if he called it Greenland, they would come, even though Iceland was more green and Greenland is more ice. Anyhow, Greenland is mostly covered by ice sheets. But this is where, I don't know if you remember several years ago when they talked about, a big chunk of ice like the size of Rhode Island breaking off, or Manhattan, that came out of the ice flows in Greenland. And so we're still seeing some significant decrease. And for the first time now, you can actually go online and you can look for like cruises that go through the Northwest Passage. So if you remember back to your American history, that Henry Hudson, that's one of the things he was looking for, was the Northwest Passage, was a way to get over the top of the North American continent to get back over to Europe, as opposed to going around the bottom, to get over to Asia. And so you can actually, in the summertime now, you can book cruises where you can go through the Northwest Passage, because the ice that's in here is now it's now free of ice in the summertime, which is a significant decrease in ice than what it was even 100 years ago. Some more receding. So this is in Europe, and these are real photographs from 1875 into 2004. So we're losing both sea ice and our alpine glaciers. This one's in Alaska. So yeah, from 1914 to the same glacier in 2014. So this bottom picture here is kind of taken like around the side of the lake over here, which is this part right here, like this, actually this part right here is this right here. So the ice came out all the way around the corner and down to about here. So we're looking at all the way around the corner to about here was where the ice used to go. So it used to fill up this whole space in here. So we put more water into the oceans and we thermally expand it and make it bigger. Well, just like water would fall out of our cup, the water is going to go somewhere, and so it's going to come back up onto land. And so when we think for a minute about what's on our coastlines, like what areas and what important economic centers we have on our coastlines, the majority of the economic centers in the entire world are on the coastline, and most of them are at sea level. So you think about London, LA, Portland, most of your major economic centers in Europe, most of them because they originated where they were easily accessible by ship. Um, they're also very susceptible to seawater rise. And so when we look at what could happen because of the sea level rise, we'll come back to this one here in just a second, but we look at a significant impact due to flooding, and not just an environmental impact, but also an economic impact to that flooding. So our sea levels dip. On this one, what we're looking at is sea levels dipping, and what you're going to see here is as you're looking at these dips down here where the sea level was down really low, these were times where we had more sea ice. So more of it was locked up in ice caps, and less of it was um, in the ocean at that point. Then this was our last major ice age, and the warming when we came out of it. So once again, looking at sea level rise. So this is data taken from the South Pacific Ocean, and we're looking at sea level rising from the 1700s to 2010. And this picture here, the Maldives Islands, oops, that out of the way. I don't know if you've ever heard of them, but they're coral atolls, which means that they're built on top of coral reefs. Essentially, the coral built up, and then sand started to catch in there and everything. So these are really tiny. I mean, you can kind of tell these are houses in here. So they're really tiny islands. But if sea levels rise by they don't even have to go up quite 88 centimeters. If it goes up, 20 centimeters or so, you're going to lose most of this island right in here. So some areas, especially our smaller island nations, are going to be much more impacted. But even our larger nations, when we look at the United States, so if we looked at a 10 millimeter rise per year, looking at a lot of shrinking of our landmass in areas, particularly in our coastal areas, and how is that going to impact our economic centers? So this would be very extreme, like if all the ice melted, which is unlikely to occur. But if it did, you can see that we would lose pretty much all of Florida. You can see the Mississippi River Valley would be less of a valley and more of like an inlet. And all the way up, we think about all of our economic centers along the eastern seaboard could have a significant impact economically. So when we think about how should we be putting off the conversation about climate change and what those impacts will be on not, and this is just the United States, but also on the rest of the world, I don't know that it's a conversation that we can afford to not have.